By the end of this lesson, you will understand the broad pattern of water and land on Earth and why the water people can readily use is limited. Imagine seeing Earth from far above. A bright blue world hangs in darkness, while a small glass of drinking water sits beside it. The two images seem to tell different stories. Let us investigate how both can be true. The broad blue areas cover most of the visible globe, so Earth appears blue from space. All Earth's water together is called the hydrosphere, the term shown around the whole planet. Notice what the whole globe is showing us. The hydrosphere is all Earth's water. The large blue surface areas are the clearest visible clue. Water spreads across much larger surface areas than land, so blue becomes the strongest color seen from far away. The word hydrosphere gives one name to all Earth's water as a complete part of the planet. This explains the color seen from space. Water makes Earth appear blue. The larger water-covered surface dominates the view. Use the largest feature in the globe image. Why does Earth look blue, and what is the hydrosphere? Let us connect the two clues. Earth looks blue because water covers most of its surface, and the hydrosphere means all the water of Earth. The blue surface and the hydrosphere bracket support both parts of the answer. Next, we will separate landmass from the salt water around it. A large, continuous area of land is a landmass. The broad ocean water around and between landmasses is salt water, as the matched map callouts show. Keep the map's two surface types separate. Landmass is land, ocean water is salty. The matched callouts make the contrast easy to see. The connected shape lets us recognize a landmass, while the blue area spreads around and between it. Because ocean water contains dissolved salt, the surrounding water belongs to the saltwater group. The boundary gives us the map reading clue. Coastlines separate landmass from salt water. Following that edge shows where one surface ends and the other begins. Trace the edge between the two map areas. What is a landmass, and what kind of water surrounds the large land areas on the map? The matched labels reveal the distinction. A landmass is a large, continuous area of land, and the broad water around it is salt water. The connected land shape and the surrounding blue area show the two meanings. Next, we will compare salt water with freshwater and its main sources. Ocean water belongs to the saltwater group. Rivers, lakes, glaciers, and groundwater belong to the freshwater group, showing that Earth's water occurs in different kinds and locations. The grouped pictures give us a clear sorting rule. Ocean water is salty, 4 shown sources are fresh. The category depends on the kind of water, not simply on seeing water. Ocean water is salt water because it contains much dissolved salt. Freshwater can flow in rivers, collect in lakes, remain frozen in glaciers, or be stored below the surface as groundwater. This corrects an easy mistake about Earth's water. Not all Earth water is freshwater. Ocean salt water belongs to a different water category. Sort each source by the heading above it. Which water sources in the image are freshwater and which source is salt water? Now check the complete grouping. Rivers, lakes, glaciers, and groundwater are freshwater sources, while ocean water is salt water. The right panel holds the 4 freshwater sources, while the left panel shows ocean salt water. Next, we will see how small the freshwater share is and how little is readily usable. Only a small part of Earth's water is freshwater, and the readily usable freshwater share is even smaller. The tank, jug, and cup show this shrinking relationship without giving exact amounts. The container sizes reveal the main proportion. Usable freshwater is the smallest share. The model is qualitative, so it shows the relationship without claiming an exact number. Some freshwater is frozen or stored underground, so it may be difficult to collect and use. A large total amount of Earth water can therefore contain only a very small, readily usable share. Now connect the two shrinking steps. Freshwater does not always mean readily usable water. Location and form can make freshwater difficult to use. Read the containers from largest to smallest. How do the three containers show the amount of freshwater that is readily usable? The size pattern gives the answer. Freshwater is only a small part of Earth's water, and the readily usable part is even smaller. Each smaller container represents a smaller share of the total. Next, we will use hemispheric maps to compare where land and water are spread. Matched hemispheric maps show more visible land in the Northern Hemisphere and a larger spread of water in the Southern Hemisphere. The shared legend reveals that land and water are unevenly distributed. The same legend lets us compare fairly. Land and water are unevenly distributed. The two hemisphere maps show different surface patterns. Because the two hemisphere maps use the same scale and legend, their different land-water patterns can be compared fairly. The difference comes from distribution, not from a change in map design. Keep the word unequal in mind. Unequal does not mean only one surface type. Both hemispheres contain land and water, but in different visible proportions. Compare the two maps using the shared legend. What unequal land and water pattern do the Northern and Southern Hemisphere maps show? The broad shapes make the pattern clear. The Northern Hemisphere shows more visible land, while the Southern Hemisphere shows a larger spread of water. The North map has more visible land shapes, while the South map has broader blue areas. Next, we will connect limited, unevenly available freshwater to water scarcity. Water scarcity occurs when readily usable freshwater is not enough for people's needs. Freshwater may exist in a place, yet the amount that can be used readily can still be limited. The two panels show why place matters. Freshwater is not evenly available everywhere. The same needs can face different usable supplies. Water scarcity depends on the balance between readily usable freshwater and people's needs, not only on whether water exists. A smaller usable supply can create a shortage even when some freshwater is present. The balance gives us the causal rule. Scarcity begins when usable supply cannot meet needs. The shortage is about usable freshwater, not all water. Use the balance below place be what is water scarcity, and why can it occur even where some freshwater exists? The smaller supply side points to the idea. Water scarcity is a shortage of readily usable freshwater for people's needs, and it can occur because freshwater is limited and unevenly available. The image compares readily usable supply with the same set of needs. Next, we will use one map task to connect the lesson's water and land ideas. The matched maps and evidence cards connect broad salt water, land masses, unequal hemispheric distribution, and the small usable freshwater share. Together, these clues solve the blue planet puzzle. Bring the map and the smaller share model together. A blue planet can have little usable freshwater. The two facts describe different kinds and shares of Earth's water. Water dominates Earth's surface, but broad ocean water is salty, and the readily usable freshwater share is very small. When that usable supply falls below people's needs, water scarcity can occur. The evidence now forms one complete chain. Surface abundance does not guarantee usable supply. Map pattern, water type, and usable share must all be considered. Use all three evidence cards with the map. Why can Earth look blue from space and still have water scarcity? Now put the complete explanation together. Earth looks blue because water covers most of its surface, but most is salt water, only a small part is freshwater, and an even smaller part is readily usable. Each part is supported by the map, the water type distinction, and the shrinking share model. You are ready to use maps and visual evidence to explain water and land on our planet.